Hello and welcome to another edition of Miss O'Day's geometry class. So we're doing 10.3 today, which is using chords. And we talked about the different pieces of a circle with 10.1, and one of those was chords. And that is a segment that goes through a circle that has endpoints on the circle. It could be a diameter that goes through the center, or it could be anything else, and that's just a regular chord. Now, a diameter creates two exact semicircles. But if you draw a different chord that doesn't go through the center, it creates a major arc and a minor arc. Remember, a major arc is greater than 180 degrees, and a minor arc is less than 180 degrees. So we're going to talk about some different theorems about chords and the arcs they create. So, the congruent corresponding chords theorem says that if two chords on a circle are congruent, then the corresponding arcs they create are also congruent. So you can pause the video if you need to copy that down. So here I have these two congruent chords, A, B, and C, D. They're congruent, they're the same length. And the corresponding arc is the one it creates, is the minor one it creates. So here I have AB, that's the corresponding arc. And segment CD creates arc CD. So if the chords are congruent, the arcs are congruent. So in this case, if AB is congruent to CD, see the line on top means it's the line segment, then arc AB is congruent to arc CD. That's why that notation is important. All right, there is also the perpendicular chord bisector theorem. So there are two big vocab words in there, perpendicular and bisector. We know perpendicular means a right angle and bisector means to cut something into two equal pieces. So this theorem says that if a diameter is perpendicular make sure you can see that. If a diameter is perpendicular to a chord, then the diameter must bisect that chord and bisect the corresponding arc. So if a diameter is perpendicular to a chord, then the diameter must bisect that chord and bisect the corresponding angle. So here I have diameter EG. So here you can see it's perpendicular to this chord FD, so it bisects it. So those two segments are congruent. It's also bisecting the arcs, so the arcs are congruent. So in this case, if EG is perpendicular to FD, if EG is perpendicular to FD, then I know FH is going to be congruent to DH, those line segments, and the arcs FG are going to be congruent to DG. And then one more theorem, we have the perpendicular bisector converse. So this is starting with the diameter is perpendicular. This is starting with a chord. That's the converse aspect of it. So if a chord is a perpendicular sorry, let me zoom out a little bit. If a chord is a perpendicular bisector of another chord, so it's making a right angle and splitting it in two. So if a chord is a perpendicular bisector of another chord, that original chord must be a diameter. So here on this picture, I don't know that this is a diameter because it doesn't have the center. I don't know it's going through the center. All I know is that it's a perpendicular bisector of this other chord. So by this converse, it's creating this right angle and it's bisecting it, so SQ must be the diameter. So let's just use those theorems. We have here, given circle M, find HK and the arc HK. So I want to find the length of the segment, and then I want to find the degree measure of the angle. So the segment, this is the diameter, it's perpendicular, so I know that's bisecting these two things. So if NK is 7, HN is going to be 7. So HK would have to be 14. And then if it's bisecting the angle as well, I can set these equal to each other, solve for x, and then plug it back in. So I know the arc HJ is going to be equal to the arc JK. So 11x equals 70 plus x. Subtract x from both sides. You get 10x equals 70. Divide by 10, you get x equals 7. And then if you plug that in, you're going to get 77 and 77 degrees. So the measure of HK is going to be those added together, and that gives you 154 degrees. That's not a 0, it's a degree. So because that's a bisector, we were able to do all that. All right, this next piece, these are two separate questions, just using the same picture. So here I have these two congruent chords. The first theorem, the congruent corresponding chords theorem, said that if the chords are congruent, the arcs are congruent. So AB must be congruent to BC. So the first one says, if AB was 110, what's BC? Well, I know they're congruent, so that one's also going to be 110 degrees. All right, well, what if AC was 150? If AC was 150, what would be left over? Well, if you subtract 150 from 360, you get 210. So this whole big thing is made up of 210, and if they're equal, each piece is going to be half of that. So it's going to be 105 degrees. Right? And our last example has this diameter that's perpendicular. The diameter is perpendicular, so I know this is bisecting. So the first question says, what's CE? Well, like last time, I know it's bisected, so if CF is 5, EF is going to be 5. So CE is going to be 10. And the arc CE, that's different. It's asking for this degree here. So again, we're going to set those equal to each other and plug in x. So I have 9x equals 80 minus x. add x to both sides. I get 10x equals 80. Divide by 10. X is 8. If I plug each of those in, this would be 72. This would be 72. So together, they are going to be 144 degrees. All right, so that's the first part of the chords. Please watch part 2 next.